So let's do a quick review of the microscope, and here at Bishop Amat we are using what is called a compound light microscope. Now a compound light microscope is such because it has two lenses. You're going to look through an objective, which are the lenses on the bottom of the nose piece, which are looking through the stage, and you have the ocular, which is the eyepiece, which is at the top of the body tube. Now, it is a compound light microscope because we are going to provide light through a light source. Now we know the prefix micro means small and scope refers to vision. So a compound light microscope allows you to look at small specimens through the emission of light through compound lenses. So we are going to look at the first lens, which is the ocular. We also call this the eyepiece. This is the viewing lens. This is where we look through to see the specimen. And for our microscopes, the magnification of the ocular is 10 times. So if you're looking through the ocular alone and looking at a specimen, it will enlarge the specimen up to 10 times. The ocular rests on the body tube, which is a support structure that has a length that is proportional between the ocular and what are called the objective lenses to gain the best possible magnification. The body tube is attached to the body of the microscope, and the body of the microscope is where the mirrors are housed, and the mirrors are going to take the image from the objective lens and direct it through the ocular. Now, because we are looking through this microscope and seeing an image through mirrors, we know that the images we're going to see are going to be in reverse, and we'll talk about that a little bit more later. The revolving nose piece at the base of the body is a device that allows you to rotate the lenses into position, and for our microscopes, most of our microscopes, we have 3 objective lenses, and those lenses can be rotated without moving any of the other structures of the microscope by simply revolving this nose piece, so we can go from the shortest lens to the longest lens without any problems. Now the arm of the microscope is the support structure for the body and connects it to the base, and we also use this as the handle when carrying the microscope. Remember that when we carry the microscope, we place a hand on the arm and we place a hand underneath the base, always carrying the microscope with 2 hands so we don't accidentally bump into anything, or if we get bumped or jostled, we do not accidentally drop the microscope. Now the stage of the microscope is this flat area here where we're going to place the slide, and on that stage we have stage clips that hold the slide in place, so when we are revolving the nose piece and moving the objectives, or we're changing the adjustment using the coarse or fine focus knobs, or if we're changing the light by adjusting the diaphragm, our specimen on the slide on the stage will not move. Our microscopes have a light source, and this of course is an electrical light source. Older microscopes actually used mirrors that you had to direct towards the sun, but we are fortunate today that we have these electric microscopes that give us a constant illumination from this source. The base of the microscope, of course, is the support structure. It also houses the light source and gives support to the entire microscope. Now our microscopes typically have 3 objective lenses, and these are magnification lenses that allow us to view the specimen at different size magnification. Our first objective lens is called the scanner. It is the shortest lens and it has a magnification of 4 times. So if you're looking through the scanner alone, it will enlarge the object 4 times. We also have a medium-sized objective called the low power. Please do not confuse the scanner being the shortest as the low power. We'll talk about the importance of the scanner in just a moment. However, the middle-sized objective is the low power objective, and this has a magnification of 10 times. So if you're looking through the low powered objective on its own, you are going to have a magnification of 10 times. The longest objective or largest objective on our microscopes has a magnification level of 40 times, and this, again, looking through this objective on its own, will magnify the specimen up to 40 times. Now, what is important to understand is that each of these objectives have a different field of vision. The size of the viewing field is different as you go from the shortest to the largest objective. Now, our scanner, which has the magnification of 4 times, actually has the largest viewing field. And this is why it's called the scanner. This allows us to scan the largest part of the slide when we are trying to identify our specimen and make sure that it is in the center of the viewing field. The low power objective has a smaller field of vision, about half the size of the scanner. The low power again has a magnification of 10 times. And then the high power objective actually has the smallest field of vision. Now, what is important to understand here is as we move from scanner to low power to high power, it is essential that we place the specimen in the center of the viewing field so that when we move from each objective, from scanner to low power and from low power to high power, that the specimen is always in the center of the viewing field. Now, on our microscopes we do have a pointer which is located in the ocular that always points to the center of the viewing field, and that is how we're going to always identify where we're going to place the specimen. Now, underneath our stage we have a device called the diaphragm, and this has various openings to allow different amounts of light through the stage opening. Now, this helps to change the contrast on the image, which will help us to get the best clarity when we focus on the image. So remember, if you have too much light, you may not be able to get a fine focus. If you have too little light, it may be difficult to see the specimen. So use the diaphragm whenever you need to adjust the amount of light. And every specimen, because of the thickness of the specimen or the amount of matter in the specimen, needs a different amount of light in order to see it clearly. Now, we have 2 adjustments on our microscope. One is called the Coarse Adjustment, and this moves the stage up and down, and it actually moves the stage pretty rapidly. We will never use the Coarse Adjustment with the high-powered objective. In fact, we shouldn't use it on the lower power objective as well if we've done our job focusing on the specimen using the scanner. However, sometimes we may have to use the coarse adjustment slightly using the low powered objective. It is the reason we never use the coarse adjustment with the high powered objective, the largest objective, is you can actually run the stage up into the objective and crack the objective lens or crack the slide. So we want to make sure we do not do that. So please do not use the coarse adjustment with the high powered objective. We also have the fine focus, and this, as it says, is to bring the specimen into fine focus. It actually does move the stage, but it moves the stage very minutely and allows us to get the best possible focus on our specimen. Now, as I said, in all of our microscopes, in the ocular there is a pointer, and this pointer is there to help us find the center of the field of vision. So whenever you locate your specimen, try to adjust the slide on the stage so that the specimen is at the tip of the pointer, and that way when you go from scanner to low power to high power, the specimen will always be in the center of the viewing screen. Now, as I said, the scanner is the shortest objective, and this has a magnification of 4 times. It has the largest field of vision, which allows us to search the slide. We can use coarse adjustment to focus on the specimen and identify the center for the specimen. The second objective is the middle-sized objective. It is the low power. Remember, the shortest is not low power. It is the middle-sized objective that is low power. This has a magnification of 10 times. Please make sure to recenter the specimen when you transfer from scanner to low power, and use the fine focus and the diaphragm to adjust the focus and the light to improve the best possible clarity of the image you are looking at. The last objective is the longest objective, and this has a magnification of 40 times, and we use this only with the fine focus, and we can still use the diaphragm to also improve the clarity and contrast on the image. Remember, when you go from low to high power, you do not have to adjust the stage. You simply have to make sure that you move the high-powered objective into position slowly so as not to crack the slide, and never use the coarse adjustment on the high-powered objective. Now, because we have a compound light microscope using two lenses, we are always going to use the two lenses magnified together. So therefore, our ocular having a magnification of 10 and the scanner having a magnification of 4, this is 4 times 10, giving us a total magnification of 40 times. So when we are looking through our compound light microscopes, using the ocular and the scanner combined, we can magnify our specimens 40 times. Now, the middle side objective, which is low power, has a magnification of 10. Combining that with the ocular will give us a total magnification of 100 times. And lastly, our high-powered objective has a magnification of 40 times, so 10 times 40 gives us a total magnification of 400 times. So for our compound light microscopes, we are going to have a total magnification of up to 400 times. Now, to remind you, we do use our specimens with a wet mount. Now, when we get this, we get a clean slide. If your slide is not clean, please make sure to clean it to remove any residue from previous usage. You're going to place a drop of water on the center of that clean slide. You then place the specimen in the center of that drop of water. You can use forceps or a probe. Try not to use your fingers because we don't want to get any oils or dirt from our fingers on the slide. We are then going to place a cover slip at a 45-degree angle on the edge of the drop of water. We allow the cover slip to fall, which hopefully will push out most of the bubbles, and then we can tap gently with the handle of the probe to push out any more air bubbles. Once we have our wet mount, we're going to place it on the stage of the microscope and secure it with stage clips. We always begin with scanner to locate the specimen using the largest field of vision. Line up the specimen in the center of the field with the ocular pointer. We then use coarse adjustment and then fine adjustment to focus on the specimen. Once we have the specimen in place and centered in the viewing field and at the best possible focus, we can rotate the nose piece to the low-powered objective. Do not change the stage placement. These microscopes are built so you can rotate from scanner to low power to high power without changing your coarse adjustment. We will then use the fine adjustment to focus and center the specimen with the pointer. We will use the diaphragm to adjust the amount of light to gain the best possible contrast and the best possible focus on the image for clarity. Lastly, we will then rotate the nose piece to the high-powered objective. Do not change the stage placement, and then continue to use the fine focus and the diaphragm to get the best possible focus on your image. Hopefully this is a nice review of the microscope for your final. Have a great day.